In this video, we're going to show you how to make a bumper switch for your BitsyBot. So we've got the wires connected to 1 and 3, the power's connected to 1 and 3, and you can see the LED light up there. And then when we switch the power to 1 and 2, the LED turns off when we push the switch instead of turning on. So we want to connect the wires to 1 and 3. We're just going to double check this with our multimeter. And so when we connect the contacts to 1 and 2, you can see that it turns off when when the button is pressed, and then when connected to 1 and 3, it turns on when the button is pressed. So we want to connect to 1 and 3. And you can see there's a 1 and 3 really small on the lever switch there. And you can buy micro lever switches like this from Radio Shack or a variety of places online. And so now we've got our alligator clips, and we're going to bend the wire around the 1 and 3 contacts so that we can get a good connection. And then we're going to solder those wires in place to make sure that they don't come out. And we're using our needle nose plier to squeeze the wire against the connection there. And I've already put some solder on those connections to make them a little easier to solder to. There we go. We got the first wire in place. And the number 3 connection, we're going to just clamp that down, and then we'll go ahead and heat it up, and we've got that soldered in place too. So now those wires are soldered well, and to make sure that the connection's good and that we got everything soldered correctly, we're going to go ahead and turn on our multimeter and check the ends of the wire. So we'll strip the ends of the wire off there and use some alligator clips, and we'll clip to the ends of the leads on our multimeter. And that way we can make sure that, yeah, in fact, the switch is wired correctly and it's working. So now we're going to take the outer housing that surrounds the bot off, and we're going to try and position the switch. So we're going to drill some holes, and we'll use the holes that are actually in the switch as a guide for our drill. It's important that you make sure that you don't drill into your fingers when you're doing this kind of close work. So you want to keep your fingers away from the drill bit itself. But we've positioned that switch so that it is right off of the edge of the BitsyBot. So it sticks out over the edge, you can see right there, sort of tangent to the circle. And that'll be important when we get the rest of our connector there in place. And we've put the screws in upside down, and that's so when we put our speaker back in place, the bolts that are protruding won't interfere with that speaker, so that's why they're sticking up from the underside. So we're just tightening those down again with the screwdriver and the needle nose pliers, and we just use 12 gauge solid copper wire, and we're using 12 gauge solid copper wire, and the reason for that is that it allows us. It's pretty stiff, so it'll allow us to extend the lever arm of our switch considerably. So anything that gets in front of our BitsyBot will be able to trigger its bumper switch. And this is a bit of an improvement over the previous design. So we're just drilling a hole in the back there, and we're going to put a screw in, and that screw it's basically a machine screw, and it's going to hold our lever made out of that wire in place. So we just twisted the wire around like a snail, and now that the wire's in place, we can bend it so that it makes the right kind of connection with the switch. And this takes a fair amount of sort of trial and error. But once you get the wire bent correctly, it'll trigger the switch every time, and it'll extend the reach of that switch. So you only need to use one switch instead of, say, multiple ones. So we're just going to get our bolt there and tighten that down. And now it's really important that nut and bolt and the washer that are holding that wire in place are tightened very tightly. Because if the wire slips, it won't trigger. It won't return to its location. It'll just sort of move and hold the switch down. So if you want to make sure that the wire's tight, really tight, so that the bolt is really tight, so that the wire doesn't stay pressed against the switch, so that it returns to its original location. So it's really important to tighten that all the way down. So we're going to do the same thing on the other side, and drill the holes out for the switch on the other side. So now that we've got the switch on the other side drilled out, we're going to go ahead and install our nuts and our screws. And this is actually a good example of a term called poka-yoke. And that means basically it's a Japanese term that refers to designing parts in such a way that they can't be installed wrong. And so this part is not poke-yoked. It's actually, the switch is in backwards, and I hadn't realized that it was in backwards until I put the switch extender, the green wire that's the 12-gauge solid core copper with a little snail tail in. So I snake that around the screw that's right next to the switch, and then I realize that it won't trigger the switch because the switch is in backwards. So in industry, sometimes if parts are designed very similarly, somebody may put the wrong part in, or they may put the part in backwards because it's so similar. And so what they'll do is they'll design it with some features so that that can't happen, and they call that poke-yoking. And so this is not poke-yoke, so I take the switch back out and flip it around so that the lever extends off of the edge of the radius of the circle, tangent to the circle, so that when the switch extender or that 12-gauge wire pushes against it, it will cause the switch to trigger and allow us to reverse direction or perform a number of different functions. Again, it's important to tighten that switch down pretty snugly, and those switches again can be bought from anywhere, from like Radio Shack or any place that sells lever switches, and they're not very expensive. So now we're going to wire the switches, and we're going to take two of the leads, one lead from each switch, and run it to the positive terminal on our board down there. So this is the extender board, or the power distribution board that we created, and so you can tell the positive side because it's got a plus on it, and we've run a red wire to it to power it. So we're going to take two of our switch wires and run them to the positive side of our power distribution board and connect them there. So now that we've got the power distribution connected, the ground wires connected, we're going to take a look at the initial sketch for our code, and looks like our bumper switches are A5 and A4. The rear is the A5 and the front one is the A4. So those are the analog 5 and 4 connections. So that's around the other side of our breadboard there. It's close to between 24 and 30 on the breadboard. So the rows 24 and 30. So we're stripping our wires and getting those set up and those are the wires that are coming from our switch, the other side of our switch. And before we connect those, we're going to use some 10K ohm resistors. These 10K ohm resistors are going to help to limit the current there for us. And we're going to connect the switch wire to one side of the 10K ohm resistor, and on each resistor. And then we're going to connect the other side of the resistor to a ground wire. So we're going to cut our ground wires there, and then again strip the ends of the wires so that we can make contact. And we're going to connect those ground wires to the negative or ground side of our power distribution board, which is underneath our Arduino. Got to kind of thread them in there, and then we'll run those over back to the same location on our breadboard as our 10K ohm resistors. And once we get them back over to the same location, we'll strip the ends of them off, and we'll connect them to the same row as the other side of our resistor. So now we're ready to connect the setup to our Arduino. So again, we're going to go to pin out A5 and pin out A4, and we'll connect those to the same row as the green wires that you can see there are connected to. Those are our switch wires. And so now our circuit is ready for our bumper switches. So now it's time for us to double check and see if those things are working. And before we do that, though, I think we're going to reattach our speaker. We had to move our speaker so that we could pop it up out of the way so that we could get to the lever switch that we installed. We needed to be able to put those screws in, and they actually sit underneath where the speaker is. So we had to move the speaker. Now we've reinstalled it, glued it back into place. That's one of the great things about hot glue. It does pop loose easily. So now we're going to test the device, and you can see it's running there. We've got some code running on the Arduino, and when we push on our bumper switches, it causes the motors to stop like it's supposed to. The code will be available on our videos for the Arduino, and we'll also create a link for that when we post those videos as well.